Okay, for this screencast, we are going to do the Taylor series expansion of e to the x. Okay, so first I'm going to create an x vector. X equals, I'm going to go say -2, 2, 2, and then y equals e to the x. Plot x comma y. I'm going to throw a clear, a CLC, and a close all. I'm going to hit F5 and I should get a plot, and plot's over here, and here we go. Okay, I'm going to throw a grid on. I'm going to do set, I'm going to do fig equals figure, set fig comma color comma white. I'm going to label my axes. And it keeps popping up over here, I don't know why. Anyway, there we go. So there's my e to the x axis. I'm going to add a line width 2 here. Okay, so now what I want to do is I want to use my x vector and create a y estimate using the Taylor series expansion. Okay, now if we come down here, you'll see the Taylor series expansion in its full glory is this guy here. It's the value of f at a plus f prime of a over 1 factorial times x minus a, yada yada yada. It's a summation. Here's a summation here, so we're going to use a for loop. If we go down to e to the x, here it is, here is e to the x. So it's x to the n over n factorial. So it's 4, n equals 1, 2, and then here's where you have to decide what order you want. I'm going to make n a variable, so I'm going to say I'm going to do first order first. So n equals 1 to n, so I have a little n. And then all I need is, I'm going to make an empty vector, y estimate is 0 times y. And I'm going to say y estimate is y estimate plus, and then just this function x raised to the n, x dot hat raised to the n. All of that, dot divided by factorial of little n. And that should be it. So now I'm just going to do plot. I need to throw a hold on here, plot x comma y estimate. I'm going to do it in red with a line width of 2. I'm going to do a legend, and I'm going to say, what am I going to say? The first one is the actual graph, actual function, and this is Taylor, and then the other one is Taylor series expansion. I'm going to hit F5, and what do I have here? Let's see, we have an error somewhere in the code, I believe. Let's see what is happening. The Wikipedia has an error. That's hilarious. Oh, no, it doesn't. Wikipedia is fine. The function here, n equals 0. I have to start at 0. That was my fault. Okay, so I started at 1, I got to start at 0. Everybody look at here, see n equals 0, n equals 0 to infinity. So you got to start at 0. So here we go. Boom. All right, there we go. Now we're okay. So now we've got the Taylor series linear expansion, e to the x. And so now I'm going to go over here to n. I'm going to change it to 2. Now we have a quadratic approximation. I can go 5th order, and look at this. 5th order matches extremely well. And that's it. That is Taylor series expansion in a nutshell. It's actually pretty simple. Good luck.